I'm sure the guys here will be happy to answer your questions along the way. So, yeah, so please mute yourselves until you have a question, and then we'll answer the question if you ask questions. Thank you, Ana Maria and Henrik.
Welcome. Okay, thank you for the invitation to present these two hydraulic joints from Fior Gentz. We should start with sharing the screen, and then I'll just go ahead and we start with the ankle joint, and then we will do the knee joint. Yeah, just ask if you have any questions. I'm doing that now. Okay, so this is basically the presentation we had at the ISPO meeting in Leipzig in May. And these two joints have been, well, the HiSWING already was launched last year, but the Hytronic was launched in April of this year. We will go through the different functions of each of the joints, operation of the hydraulic system, and some benefits for the patients, advantages for the orthotists. Now, starting with the ankle. Usually the procedure of making the orthosis requires the alignment. So you have the first step would be the work alignment on the workbench, where you just check that the orthosis has the center of mass, which is like the center of the thigh. Will go the line from the plumb line falling from that point to the foot will fall anterior to the knee joint, and at a space or a place which is in this middle one third of the foot. That's the suggested alignment for our orthotic joints, and it corresponds actually to our physiological standing position. So if you have now, after the bench alignment, you have the static alignment on the patient, you would have the same situation, center of mass running through the middle of the thigh, or here anterior to the knee joint and down to the base of support. Of course, you will also have the dynamic alignment, and there's quite a few things to check there. That, of course, that the gait goes from the heel contact to toe, and that all of the phases of gait are met as good as possible, as closely to the physiological gait as it's possible. There you see that the center of mass is always going on a smooth curve, so as to save as much energy as can happen with the use of the orthosis. Now we look at situations like going up the hill and down the hills, or ramps or stairs, and we see that the center of mass is not always aligned when people are going uphill and downhill. So if you go uphill here, you will see that the trunk leans forward, and this center of mass will be much more forward than usual for the orthotic user, with a limited range of motion at the ankle and not enough force at the leg. You need to make some adjustments in the alignment so that the body doesn't have extra effort to go up the hill or down the hill. We like to keep the nice physiological position going up and down the ramps or hills, and that's exactly what this orthosis is made for. You see, this is the situation of the patient. Trunk leans forward, center of mass is still on the base of support, but there's a quite unstable situation here. Going downhill, you have a lot of stress on the quadriceps. You have extreme flexion moment. And to avoid that, you have the Neuro HiSWING. The Neuro HiSWING is a hydraulic ankle joint, and it is a hydraulic ankle joint because it allows alignment changes through this hydraulic channel. Okay, through this oil channel that or the hydraulic function is actually there to allow changes in the alignment. So I want to insist here that it's not a hydraulic joint for function, which is it's not providing assistance or resistance to the movement. It is only allowing the change of the alignment to compensate for the situations like going up and down the heel and some other moments that are needed, where you need to make the alignment changes. Okay, here we go. Looking at the, I'm gonna take this off. Looking at the function of the joint inside, you will notice once you open this valve or you open this, it's like a little door here that you can use to change the alignment. You see this water level. This water level will always be in the correct position, which is a tibial inclination that has been set for the patient at the bench alignment and the static alignment. Okay, now we see that channel here. You open that valve and you allow the fluid to go from one chamber to the other. And in this way, you can move or make more or less inclination of the tibial section. This level here is there to give the patient a guide as to where they have to close the valve again. See here, filling up on one side. There you have your new position. Now, if this patient were on a hill or on a ramp, then you will have that again, the water level at zero, at the neutral position. There you have the possibility, like with, okay, here's showing basically that you need to place the level on the neutral position as a guide for the patient. So Henrik, if you feel you have to to say anything, okay, just go ahead and say it.
Yeah. Okay. What we see here on the video is that you have the spring force that we have in the Neuro HiSWING is exactly the same spring force that we can use from the Neuro Swing or the Neuro Swing 2 or the Neuro Swing H2O, and we have the possibility, and this is the main goal of this joint. This is the first joint where the patient is able to rebuild the correct alignment when he goes uphill, downhill, or for me, it's much more important if you wear different shoes with different heel heights. So what we've seen here is now in the last step where the water level was leveled out correct. This was the position directly. This is what the technicians made for the patients. So they level it in the correct position. And then the patient knows, okay, this is my alignment. So this is the alignment that the technicians decided for me. And when he now walks up or downhill, or when he changes the shoe with another heel height, for example, most of the sport shoes have a 1.5 centimeter heel height. And when he changed to a heel height to 3 centimeters or something like this, then normally you have automatically, with all of other joints that we have in the market, the situation that we change the whole alignment because we have more space under the heel. So we have a more tibia forward position, inclination. And this affects to the whole joints from the floor up to the center of mass of the body. And to correct this, the patient can open the lever, can bring this water level in the middle again, and then you have this position with this new heel height or with this situation downwards or upwards the slope. And this is really interesting and important to know because right now, if we be honest, the patient only have the possibility when we build an orthosis for one shoe with one heel height. we lost the possibility to have the patient always in the correct alignment, because every one of us not only wear one shoe with one heel height, so he is more flexible by changing the shoes or in the surfaces when he walks outside, and so the patient can be sure that he has always the correct alignment.
Okay. Yes. Okay. Then I go ahead with the next adjustment here, which is the springs. The springs can be exchanged like with any other Neuro HiSWING joint. And it's a little different because you have now that unit there, the part of the hydraulic unit. So you would have to open the bottom part to exchange the spring and put it in through the bottom as well, which means we don't have the range of motion adjustment in this case. Okay, same as before, you have the selection of the springs. You can use one of these 5 springs according to your alignment and the dynamic gait of the patient, what you have selected, as if it were any other Neuro HiSWING joint. Then we have, again, the applications going up and down the heel. Here's also a video of how the patient would manage that situation.
So what you now see is that this is a position we decided on a workbench and on the static alignment for the patient. And afterwards, we made this dynamic process, and we found out that the center of mass is now over the middle. When we have the situation that the patient walks uphill, then normally the center of mass goes in front of the knee and of the hip, and he always walk with this, I would like to say, with a duck butt, that he pushes outside to recreate the correct alignment. Now he can open the lever, move it in front, and you can see it here on the water level that you just bring this little air bubble back to the middle. And when he now stands straight and walk upwards, it is possible that the patient is back in his alignment that we decided for.
Okay, important here is that they always have to close that lever to make sure that the position is kept. It's not to be, shouldn't work with an open lever. It shouldn't be used with an open lever. Okay, patient standing straight now. Any questions until now?
Now, same situation. This is our alignment that we made before. Different, now this is downhill. And now you can see when we walk downhill with an orthosis joint that is just strict in this alignment that we planned before, we have a knee flexion load on the knee. It depends on the movement of when you have heel contact downhill, then you have rotation movement from the back of the heel up to the knee. And here's the same. You can open and close the lever and bring the orthosis for downhill walking into this position. When you see, I like to be honest, it makes sense when people walk a long distance downhill or uphill. When they just have a small slope in front of a building or something like this, it is not necessary. So they can walk just the slope upwards like this. This makes absolutely sense for people who live in areas where a lot of hills and mountains or something like this, where they walk over a long time.
Correct. This is very good to have for people living in hilly areas. The other application possibilities we have here comfort when sitting. Patient can just open it up and just relax. And here again, make sure that the patient, when they stand up again, that they have replaced the position and closed the lever.
There's a question in the chat. To change the alignment, does not patient flick something in the joint? Is there any problems with weight being on the joint when the lever is being adjusted? And yes, but more not. If they have too much pressure on the on one of the springs when they when they open the lever, then it could be possible that the joint is still locked because we have pressure on the valve. The only thing the patient have to do is after he opened the lever, he just have to move into forwards and backwards so that the valve is one time without pressure, without oil pressure, and then he can exchange it, exchange the angle without problems. So yes, when he have pressure on the valve, then nothing happens. He have to remove the pressure from this valve, and yeah, and the only thing he have to flick is to open it on the down part here, to open this lever arm and to close the lever arm. This is this thing the patient must be able to handle. So it makes, and this is also a thing, I would be honest, we know that there's that is sometimes a little bit problematic to plan this joint together with a locked lever, with a locked joint on a knee. Not all of the patients are able to handle it. But in an AFO, we made a lot of tests. In AFO, it makes absolutely sense. Most of the patients, even if they have a stroke or something like this, when they train and when they are fit enough, they can open and close the lever. So we make usability tests.
Okay, then other applications here, we have the case of changing the alignment due to the heel height of the shoe. So you can always have that nice physiological inclination recommended or safe by with the bench alignment and the static alignment on the patient. Okay, the other thing that's nice is that you have the plug and go modularity with the, so you can exchange it with the other plug and go ankle joints from Fior Gentz. Of course, this is it has a high price. The HiSWING is probably not the first option for you, but you can, after having made your orthosis with a Neuro HiSWING or Neuro HiSWING 2, you can give it a try with a Neuro HiSWING because you only have to exchange the functional unit. And then, yeah, let the patient decide if it's an option or not, because they probably have to pay it from their own pocket. Okay, now we're going to the Hytronic. So to close the section on the ankle joint, any other questions about the ankle joint? Not really, okay. We have now the Hytronic, which is a hydraulic control. It is actually now a hydraulic control. It's not only there for the alignment change, it's now part of a flexion stop that is controlled through a hydraulic unit on the knee joint. So the advantages for the patients, it's a play-free joint, which means yeah, it has reduced noise, and it doesn't have if you are familiar with the Neuro HiTRONIC, it doesn't have that toothed wheel and doesn't have that, that's why it has less play. It doesn't have play at all. It can be adjusted. It's infinitely adjustable, the lock and free motions. Stepless. It has an integrated swing phase control. What do we mean by this integrated swing phase control? It's an extension support to start the swing phase. It's an extension assist. It has a low noise operation. It can be used as a unilateral design according to the configuration. And it has, of course, has to be tested with our configurator before you decide to make a one-sided joint. And it can be worn on the trousers. So we're just relating to other hydraulic units, orthotic knee joints, which are maybe much bigger, but this is nice and small and can be used under the trousers. Okay, so better compliance. There you have the function. Would you like to explain that, Henrik, please?
Yeah, it's nothing. We have here inside,
Yeah,
inside the joint we have here this this oil and this pressure, and there we have a little air spring inside of this joint. So there is also a valve inside of this hydraulic system, and to open the swing face, this valve is it is possible that it's open, and then you can flex the knee. So you can you go back and stop? Yeah. And there you can flex the knee, and you have this pin here on the back side of this joint, where that comes in, or that goes in and comes out. And this is a really special thing, because this is one special thing at this hydraulic system. We have a difference between other hydraulic systems. Normally, you have hydraulic system always connected between the upper part and the downer part, where the movement takes place. And here we have the situation that we have a disconnect hydraulic, more or less. All of this hydraulic system is just on the back part of the joint. So when the valve is open, then it is possible that the pin press inside the oil, and the air spring gets compressed inside of this joint. So that's the reason why we can flex the knee. When for the swing phase, when the patient take load of the orthosis, then this little air spring inside there, it's like a balloon, more or less, inside of this joint, can go back into this old form, so decompress, and pushes the pin with the oil upwards. So that's the reason why we have this integrated swing phase control. So this pin pushes the upper part back into the extension situation. And this is a really good and a thing that a lot of patients that are walk already with this joint that I really like, because they are nearly 100% sure that at the end of the swing phase control, they definitely reach the fully extension. Why we don't have we have more or less a swing phase control is not 100% correct. It's more or less a swing phase support. Swing phase control normally means by other joints from other competitors of us, that they control the whole movement during the swing phase. This is what we don't do with our joint, because we thought we don't need it. We need to have a physiological movement and a physiological gait and a physiological swing phase. We need more or less 60-degree knee flexion, with what is with our swing phase support absolutely possible. So it is so we are because the patients don't need so much force to bring this knee into the 60-degree knee flexion. In other systems that we have on the market, there's a situation that this swing phase is controlled. So they have to work against the orthosis, more or less, to bring the front foot, or the foot, into the front. And this is a point that a lot of patients don't like, because it is stressful for them, because it's a lot of work they have to do. And most of the patients who walk with this system joints don't have the power in the muscles to walk against this swing phase control. And when you see this situation, when you look at videos, you always will see that patients with other joints that are hydraulic systems don't have this 60-degree knee flexion, or really often don't have this 60-degree knee flexion in the mid-stance phase, which leads to compensate mechanisms. When the knee is not flexed enough for the swing phase, the patient starts to do You know what I
Circumduction.
mean. Circumduction,
Mhm.
hard word in the morning here. Or they start to lift the unaffected side up to the toes to do the swing phase on the affected side, because they don't have the space for the swing phase. And that's the reason why we say people who have a normal leg on the side that is injured more or less, they don't need a swing phase control. They only need a swing phase support, and that is the reason why we don't have a swing phase control, and we never planned a swing phase control with our hydraulic system. The swing phase control is good when the people walk downhill or alternate steps. But when you think about how often walk people downhill or upwards or downward steps, and how often they are just walk on a straight flat area, and we say we take this part to our important goal to reach it, to make it as easy as possible, and we plan our joints to the physiological situation of the patient, and we don't want that the patient have to learn to walk with our joints. So yeah.
Okay. Yes, so as a summary, we have slight extension assist at the beginning of swing, but it is otherwise not resisted, so that it can freely move into the end of swing to full extension, which makes it very easy to use for the user. Okay, now the controller has a benefit for the patient. It is now flat, a little. It's divided now in two parts, and it's a little smaller, so that it's nicely fit into or below the trousers as well. You have two-part articulated connection, which just Henrik just mentioned. The motion sensors are the same as before. You have a sensor for the swing phase, for the movement of the lower part. You have the operations as before: automatic function, free movement, and locked function. And this can be done through your telephone or through the iPhone or through this small remote controller that we can give, that it's actually delivered with the orthotic joint. Okay, now to the mode when it is locking and unlocking. It is the locking function happens. Let's see. There you are standing, walking. I have to go into it. Okay, the control detects changes from standing to walking in real time and vice versa. That it is a very fast reaction time from this controller that would control the valve if it's open or closed, and that happens in a real life situation. We have Henrik 400.
Yeah, this is what I
second.
would like to say. Yes,
Go ahead.
We take measurements. Yeah, we have the only system in the market that detects movement 400 times per second. So we have the fastest controller and the fastest measurement system on the market right now. So if there's anything, so if the patient struggle or something like this, our controller box recognizes and reacts directly in this situation, more or less, when something happens. So it detects this movement really fast. Other systems just measure 100 times per second.
Okay, so it's a fast reaction time, which makes it a very safe orthotic joint, because it would react to any changes in the velocity or changes in the position of the shank section so fast, so as to make the joint lock when needed. Okay, usually it would unlock from terminal stance during the swing phase and block already from the mid-swing before the initial contact. Easy recognition of short and low fast steps. It's because of this reaction time. You can make adjustments, additional adjustments with the expert app, as you would do also with the Neuro HiTRONIC. Now we have the joint function again.
Is it okay if I?
Yeah, go ahead, please.
Yeah, okay. So now you could see in the free function, now here the valve, you see on the downer part there is open, and it is
Lower
possible
part, yeah.
on the lower part, correct? And then it's open. And now it's possible that the oil goes through this valve and compress the air spring inside of this thing. And now you can see this this little. Is it thunder? Yeah, I don't know what the word for this blue lightning. Yeah, and this always means when you see here this video that there is the electronic system works. So now you can see in the auto mode, it's close. So it doesn't work, and it only works when we have movement on the system. So the joint is open, then it's possible that we can compress the oil and compress the air spring, and the oil can come back due to the form of this valve, just backwards, and can go back, and this air spring can decompress, and this leads to this position that the this pin comes out, and the patient comes into the extension again. So this is what happens in the automatic mode. It's just now, this is just in this video, it's just shown that this is stepless into extension.
Okay, you can also control with a lever manually the position, if it's automatic or locked or free.
Yeah. And now you unlock it. This is in just a safety situation when you have this situation, for example, that the joint is that you have no power because the batteries are empty. Then the patient always have the possibility to unlock the joint for sitting or something like this. So it's more or less just in safety mode, this pin on the downer section of the joint.
Okay, so that's free moving, and then you see this is always open. It's locked.
Yeah.
Closed. There's a little more to the video.
Yeah. What we've now shown in the video is that we can exchange if we have not the correct alignment of the orthosis. Sometimes this could happen. Then we can change it, the position here within different disc
flexion
on the flexion degree on the upper part. So now we have a 10-degree thing, and normally now, with this joint we can just change the extension stop there. We have to change also this disc with this flexion because we need the correct point on the backside. There's this pin, there's a roll on the top of the pin. And we have to take care that this form from the disc with this 10-degree disc is the correct position and have the correct position to this roll on the top of this pin. Because when we just have this 5-degree disc on it, then this could lead to a wrong force here on this point, and the roll can break. So this is the reason why we also have to change the disc part there, that the connection between the downer part and the upper part is correct, have the correct form.
Okay. So advantages for the orthotists: no certification is required, easy installation and assembly, and it can be combined with all the Fior Gentz system ankle joints with a dorsiflexion stop. Okay, this is the drawing, the technical drawing on the spare parts.
what we want to say is, I know the colleague who with this presentation, right? It's this, and this is a thing. A lot of people in Leipzig say, "Oh, is it really like it is?" If you told us, there is nothing special, more or less, at this joint. Yes, it's an hydraulic joint, but when you work with it, and when you assemble it, and when you know the Fior Gentz system, you know already how to handle this joint. Yes, you have to look how to make the correct alignments and the correct things in the expert app, but it fits to 100% in our 360-degree orthotic system of Fior Gentz. So if you use our alignment that we say that it's good for patients and everything, and when you build the first time the orthosis with all of those parts, and you have experience with Fior Gentz, it is absolutely makeable for everyone who work first time with this joint. So it's not that you have to spend extremely much money in certification or like this. We say, if you know our system and if you follow our system on our website, everyone can use this joint without problems.
Okay. We also have maintenance plans, actually, that can be seen in the website. And here's the hydraulic unit. The hydraulic unit does not need to be revised by Fior Gentz unless there's an oil leak, which will not happen very often. We have can be used 3 years. And then after 3 years, you should change it or change the whole orthosis. Okay. There are any questions?
Yeah, Simon just asked if we can clarify what you mean, what we mean with 360-degree orthotics. And if it's okay, then I just share my screen.
Yeah, just go to the website. Good. Yeah.
And
Now you can see here, this is a point on our website. When you go on the online tutorials, we have here this 360-degree orthotic. And this means more or less the whole Fior Gentz system. So we not only selling joints, we have a complete system for using our joints and to have the correct alignments. And our 360-degree orthotics means we give you a guide from the medical patient history up to the maintenance of the orthosis. So we have we have a look 360 degrees through the patient. So, and normally it always starts from the beginning. That's the reason why we have this 1, 2, 3, 4, 5, 6, and up to 1 circle. And this means 360-degree orthotics. So when we talk about 360-degree orthotics, we mean the whole Fior Gentz system with all of the knowledge that we have and with all of the joints and all of the things you can buy from us to treat, to make a good treatment for your patient.
Henrik, can you also explain what happens after 3 years with the joint?
Can you show the maintenance plan? Sorry, Ant.
Does it go back for servicing or?
Mm-hmm.
Yeah, if you can explain that a bit more.
Do you explain it, Ana Maria?
After 3 years?
Yeah.
What happens after
with the
3 years?
hydraulic unit, does it go back for servicing or?
Yeah, correct.
Well,
so after 3 years, you have this situation. I don't know if Ana Maria, if you have these maintenance plans on your presentation later.
No, the presentation is through. Now we have to go through the website.
Yeah. Okay. We just let me show you. Then I go back to the website really fast. You find the maintenance plans under downloads, and we have the system knee joints. When you click here on this, my computer is not so fast today. We have, we can go here on the Neuro HiTRONIC. And I just try to make it a little bit bigger. And here it's just explained what what we have to change every 6 months, and after what we have to do after all of these things. So this is what you can do with your joint. What you can't do is to check the functional unit. This unit is the only thing here, so the number 8. This is a thing that we have a replacement after 3 years, more or less, or we have to check it. And when you want to repair it, or when you think, or when you thought there's something wrong with this functional unit, this is a thing we have to check with here at our company at Fior Gentz, because you can't open this joint, then you lost all of this oil that is inside there. And it is that you get, after this 3 years, you get a new one of this functional unit. And if in this 3 years, if there's something happen with this functional unit, you get an exchange one. So you can send this one for repair to Massons, and Massons send it up to Germany. And you get, so the patient get for this time, for the repair, a new one, a new functional unit. And if we can repair this functional unit that you already have, then it comes back to you, and the patient can use it. And if this is not possible, then you can take the new functional unit that the patient have right in the orthosis. And this is what we guarantee for 3 years, for this system.
And after 3 years, you would have to buy a new one.
Yeah.
Or is it possible after 3 years just to look at it and repair it and send it back?
Yeah.
It's not actually. It is the life of the functional unit is 3 years. So the recommendation is to exchange it after that time.
Yeah. Just let go here. We have some questions in the chat. I just want, before they are too much, I just want to follow these questions really fast.
Yeah,
What size does these joints come in, and is there a weight limit for usage? Size is a 20 millimeter system right now. We only have a 20 millimeter joint system. And weight limit, everybody who knows Fior Gentz knows that we don't talk just about weight limits, because there is a difference between a patient who is really straight on the orthosis and walks a lot, and his weight is 100 kilograms, and there's a different, or you just have a patient who need orthosis for transfer things from the bed to the couch or something like this. So it is a completely difference of force that we have to handle. So that's the reason why Fior Gentz don't recommend just weight limits. If you want to know if this joint is possible for your patient, use the configurator. And there you have to sign in all of these things, also the muscle status and all of these parts, and then we can give you a 100%, more or less a 100% recommendation if the joint fits for the patient or not. We can't just say tell it just by the body weight. This is also a thing that we really can't do. If customer ask the technical support this question, the only thing we can do is ask for more patient data to configure it. So we also in our company don't have a possibility to look at a chart or something if the joint is possible for patients with 120 kilograms or something like this. The next question is, so does this joint have, in a sense, a stumble control function? Yes, it is correct. Also, when they walk, and if there's something happen when they hang on with their toes, or if they get pushed in a big crowd or something like this, then the controller box recognize this movement as a unphysiological movement. And then the knee is locked, and the patient can be sure to, every time when he walks with the orthosis, that he is not in that he is on a safe orthosis, so on a locked joint. And the last question from Darren is: the lady in the Hytronic at Leipzig, in our LinkedIn, and this is yeah, the joint did not appear to provide knee flexion damping on ramp descent, but she appeared to be able to release the knee joint under load on a ramp descent. Is this correct? Yes, it is correct, but you have to know that this Teresa, she's also technician, and she know how to move and how to use her rest muscle function to trick the system. So it is not planned. The most of the patients are not able to do this because you have to understand to 100% what happens at what time in the joint. This is what Teresa knows because she is also one of our patients who ever get treated with the Neuro HiTRONIc. She was the one it and planned with it. So that's the reason he knows this joint to 100% and can make some movements that she can unlock the joint. Just to let you know, I was not so happy about this video on our Instagram account because it don't shows the status that every patient is able to handle. It's just a special situation for from Teresa because she trained a lot to do this. Okay, this was all the questions right now in the chat.
Okay, so then if there are any other questions, we're coming to an end now. What we could show is also, if you could put, please, again, share the screen, the new video of comparing the Neuromatic, Neurotronic, and Neuro HiTRONIc when they lock and when they unlock.
I am well prepared. Just
that
wait.
is good.
Okay. Now here in this video, you can see we compare our stance phase control systems, and the only thing what you see here that we have this is a Neuromatic and it's a mechanical joint that is locked, and here we just just make the screen bigger. Now you can see just here the gate face on the downer part, and you will see where it is open when it's locked. So this gray bars here is when it's unlocked, so when it's free movement, and here you will always see when it's locked. And the pneumatic joint locks in the loading response when the plantar flexion takes place on the ankle joint. Then you can see here there's a wire that goes up through the knee joint, and that presses this locking pawl upwards, so it locks the knee only in this phase here.
Yeah, the loading response with the plantar flexion movement, the cable goes up and presses the locking pawl.
Yeah, and this is what we say here. It's what we see with the 60-degree. What we say it's important for physiological gait. And in just by standing, this is also here when he just not. This means stance, so not the stance phase. So it's just when the patient stands, it's an open joint. This is important to know for the Neuromatic. Now here we see on this downwards that there is the Neurotronic, and you can see it is locked in the middle of the terminus ring. It starts to lock at the end of the terminus ring due to the same mid-stance phase from the to the end of the mid-stance phase like the Neuromatic. So you can see the combination you have to do it is so now you can see here the difference that this system is still locked when the patient just stands. So they must be able to stand, have enough muscle power to stand in the normal stance phase. And you can see here that it is potentially longer locked like the Neuromatic. So it's a little bit safer than the Neuromatic for the patient. And now we have the Neuro HiTRONIc. Now you can see it's locked at the beginning of the terminal swing, in the end of the mid stance, and we just have an open knee for the swing phase, and directly in mid-swing, in the mid-swing phase, it is locked again. So when we don't need this swing phase, or when we need the locked situation, then you can be sure we have it only open at this situation where a physiological gait normally is possible to move the knee. So here in the mid swing, it doesn't mean that it's strict locked here in this position. The patient can bring the leg up to fully
Forward.
extension, forward. And here you can see we have, with the Neuro HiTRONIC, we have a system that is potentially, it's the most safe system compared to our other stance phase control systems.
Okay, now let's talk about the unlocking moment. The unlocking moment in comparison to the other joints. You know, for the engaged teeth, you need an extra amount of time, or a little more extension force to make sure that there's a free falling tooth, that the teeth are not engaged anymore. But now, because that's not the situation with this, the Neuro HiTRONIC has a completely different mechanism. The extension moment is recognized, and the unlocking of the joint is quite much easier.
Yeah. So everybody knows, or everybody, you can do it afterwards if you want. We have this function videos from the Neurotronic and the Neuromatic also on our website, and then you definitely see what we mean with this. There's a wedged wheel, and the wedged wheel is built that you need extension, that the locking pawl can unlock from this disc, this toothed disc inside the joint. And this is a thing that the Neuro HiTRONIC doesn't have anymore. We just have this situation with this hydraulic. So it's directly open when it's open. So, and this is a big deal, a big thing, a big difference, and it's easier for the patient to understand what you have to do. You just have to walk. With this other system, sometimes the people don't understand that the extension moment have to take place on the knee for the unlocking system. So you can see here we only need it for the swing phase. Or it's only the swing phase is opened, and we have a lot of time where the knee is potentially locked because we don't need this extension moment anymore.
Okay, so yeah, I think we have covered all of that, all of the functions of the ankle joint, the HiSWING, and the knee joint, Hytronic. And we're coming close to the end now, so if you have any questions, this is your last chance for today. Of course, we are here anytime that you have questions.
Oh, there's a question.
Oh.
Is the locket
Locking and unlocking quieter in the Neurotonic versus Hytronic?
Yes.
Yes, it is.
Yeah,
the mechanical parts are not. Yeah.
And weight limit is which I told you before. I can't give you just a weight limit. It always depends on what is the body height of the patient. What is if the patient have deformities like in varus or valgus. We have another force situation on the joint, like if it's just a straight leg, a normal leg or something. So the weight is only one small part in the calculation for the joint. So what we can say is, for example, if the patient have okay, this is after if you have the situation, if the patient have nothing, it's just straight and it's there's no and he's not really have no deformities. The body height, for example, is 1.70 m or something like this, it could be possible that the joint, that the patient can weight 90 kilograms, for example. But if the same patient with the same kilogram cell is taller than 1.90 m, it could be possible that 90 kilograms that the joint is out of this situation. Or my colleague always says, if you have really heavy patients, then they have to be really small that it fits. So this is the difference between this. Okay, sorry, after 3 years warranty, do we need to buy a new joint? No, just the function unit, not a whole joint. We only talk about the function unit. And then what is the maximum flexion contracture that the joint can cope with on ramp descent? I can tell you what the maximum flexion load is, and I think this is, I'm not sure, a little bit over 670 degrees or something like this in a normal stance. 70, I think. I think 60 degree is okay.
It's normal.
Let me look. Ana Maria, just go on. I have a look at the manual. There we have it. I'm not 100%
exactly. That's
sure.
A good question. If you have anything that you need to know, technical information is also available through the website. So that is the first place you look for any information that you need.
Let me look. Just go on, ask questions. I just have a look.
Yes,
here.
I will share the screen and then show you also our download section. And because the manuals and everything related to the joint can be, of course, seen in the website. If I get to that, okay, there I have that.
I think it's also good to mention that if you are thinking of using the Fior Gentz parts, to go on the website and use the configurer as well.
The configurator.
Yeah, configurator.
Yeah, we always suggest that you use the configurator. Now, if you're using the Hytronic, even more, because that about the weight and the height and the deviations and anything is and the flexion contractures or anything that could affect the function of the knee joint will be there. The selection criteria will be then sent through the algorithm, so that you're sure that you can use the joint. And here's where you find the configurator, how you start it, and you get your patient data into it, very easy to use. And here you can look into the products, knee joints. And there we have the knee joints. And here you have the Neuro HiTRONIC. And that's actually the easiest way to find anything that you need to know from the function, the videos, the function videos we have just shown you. And here below you have all of the other additional information, maintenance plans or instructions for the patients, your catalog pages, your brochure, and the instructions for the technical instructions, IFUs for the orthotists. And Henrik, you have the information you needed about the flexion angle, or is it here in this IFU?
Yeah, I just looked here at the German version. Okay. I don't find it. It's called. Give me a second.
Here you see, for example, all of the settings that can be changed, all of the adjustments that are possible with through the app. Yeah, adjustment options with the expert app. So please make sure, we do have so much information in this website. And
I can't find it at this so fast right now. So
we will have to get back to Diamond with the with
we
the data. Yeah.
we deliver the informations later to Massons, and they can give this information up to you.
Yeah. There's a question about splash proof versus waterproof.
Yeah, correct. We have with this joint system, we have an IP44 rating. That means that the system, the whole electronic system is splash proof but not waterproof. The difference is splash proof. When we do this test for this IP44 certification, then the joint and the system gets splashed with water, with a lot of amount of water from all of the sides. So from 360 degrees on all of these parts. So on the controller box and on the joint. And then after this, the guys who make this certification have a look inside of the part. Is there anywhere water? And this does not happen. So that's the reason why we have an IP44 certification, and it's a splash-proof certification. When we talk about waterproof systems, then you put the system into
submerge it in water.
In water, and you let it sit there for amount of time. And after this time, there don't have to be any little water piece inside the system. And we have the situation here that we tried it to have a waterproof system, but we have a small piece of water inside the controller box. That's the reason why we just have this splash-proof IP44 rating. But it's interesting to know that you can go inside a really extreme weather situation, or for example, if patients walks with a Neuro HiSWING H2O on a beach, and then they get a wave up that comes up to it's absolutely no problem for this system. So what they don't have to do, or what they can't do, is go swimming with the system, but they can walk without problems in wet areas or something. Nothing happened.
Awesome. Is there any more questions before? All right. Well, thank you very much again, Henrik and Ana Maria. You've been fantastic. And please, guys, please reach out, help us. I mean, sorry, not help us. We're here to help. So if you have any questions that pop into your head afterwards or tomorrow, please fire it away and ask myself or Bill or Simon or Anton any questions that you might have about the Neuro HiSWING and any other topics we've mentioned tonight. But yeah, thank you for attending. It's been fantastic.